Feel like to find out the person and ask them why they find out the physics, and we all ended up taking it in high school and college and pulling our hair and dying. The bad news, neither Galileo nor Isaac Newton are here right now to ask them. No worries, it's time to embrace it. Believe me, I went through same pain and I tackled and overcomes it from not knowing any concepts clearly to got A+ in physics. If I can do it, you all will. Today we will talk about some basic concepts in physics, distance and displacement, motion and so on. If we understand these basics clearly, physics stops being an alien language and makes sense of everything. Motion is the core concept of physics. Sir Isaac Newton described motion clearly. The story of falling apples straight down inspired him to wonder why they didn't fall sideways or upward, as the legend goes, but there is no evidence it hit him on the head. But definitely it make him to think about what is the mysterious reason behind it. Those basic concepts run through almost every physics topic. There is no way to escape from one of them. They are literally tied to every concept of physics. So let's begin. We'll use clear examples so you can visualize each idea. First, what is motion? Then scalars and vectors. Finally, distance versus displacement. Let's start with motion, the foundation for both distance and displacement. Motion means a change in an object's position over time relative to a frame of reference. What is position? Position is where is the object a person. If something moves from one location to another, it's in motion. Examples: you walking down the street, a car on the road traveling, a child walking or running. To describe motion we use scalars and vectors. Scalars have magnitude only. A scalar quantity has only magnitude. Magnitude is just a value. Examples of magnitude: distance in meters, mass in kilograms, speed in meters per second. Magnitude answers how much. Like 50 miles per hour, which is speed, or 50 kilograms, something like that. If a car is moving 50 miles per hour, that's a scalar, speed. I walk to my friend house, which is 5 miles away. The 5 miles is the example of distance. Distance always add up of the total path or route. It never can be negative. It could be 0 but never negative. A vector has both magnitude and direction. If a car is traveling 60 miles per hour to the north, that's a vector because it has magnitude and direction and both. If you walk 2 miles to the east, that is a vector because you included magnitude 2 miles and direction east. But if you walk 2 miles and no direction included, then would have a scalar quantity. Now we know scalars and vectors, let's use them to describe how positions change. We'll now look at concrete examples to make this clear. Distance measures the entire path length traveled, regardless of direction. Example: your friend's house is 5 miles away. The distance to get there is 5 miles. If you go to your friend and come back, you're home. Distance 5 plus 5 equals 10 miles. Distance is always positive. It never will be negative. Distance accumulates total motion. Doesn't matter you take right or left or ups and downs and you're traveling. It's useful when tracking how far you traveled. Now let's contrast that with displacement. Displacement is the change in position from the initial point to the final point. Displacement often causes misunderstanding to students. The meaning of displacement in physics language is different than everyday language displacement. Displacement is a vector. It's the overall change in position of the object from start to finish. It doesn't accumulate the distance traveled during the path. To find out displacement, we need to find the starting point, initial position, and its end point, final position, and then subtract displacement delta x equals sign final position minus initial position. There will be a direction included too. Displacement could be positive or negative. Displacement is measured by subtracting final position initial position. To find direction for one dimension, positive is to the right and negative is to the left. After calculating the final change, whatever sign comes, it shows the direction. If it positive sign, then it's to the right. If it negative sign, it is to the left. Example 2. You walk 2 meters to the right, then 4 meters to the left. Initial point 2 meters to the right, final point 4 meters to the left. Your final displacement is final point starting point displacement minus 2 negative sign for the left. If you go 5 miles to a friend and come back home, your displacement is 0. Displacement can be 0 if you finish where you started. For example, someone traveled 3 meters east, then 2 meters west. The direction is determined by the overall change in position and calculated through the use of sign. For eastward direction typically assigned as positive. Here movement of 3 miles east represented as plus 3 miles. The westward direction is assigned as negative. Here the movement of 2 miles west is represented as minus 2 miles. After calculating, we can find displacement through final position minus initial position. A runner completing a full lap may have large distance because it's adding up all his traveling path, but displacement after a full lap is 0 if he came back in the same place where he started. Another example of displacement if there is 2 lines in the image, and it didn't come back to the same line and it's not one-dimensional and went to other way, making an angles in between. Then to calculate distance we have to connect the starting and the ending line. The connecting line is the displacement and the direction is from starting point to the end point. If it creates a right angle, then Pythagorean theorem is used. This is to calculate for 2-dimensional displacement. For straight line in one way, displacement is the total length it traveled and the direction arrow from starting to end point. For a curved line, to calculate displacement, just like before, draw a line from starting point to end point and the measure of it is displacement. But be careful about calculating the scalar quantity distance in here for curved line. The distance will be the measure of all the way traveling the curvy path. Every step of his journey will be add up. Now let's summarize the lesson. Summary: distance equal sign, total path, scalar. Displacement equal sign, final point minus initial point, or the shortest change in position with direction, vector. Practice more problems about the topics, then the concept will get more clear. See you soon in the next lesson.